Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
1910 Ernest Rutherford. Hans Geiger, The Scattering of Alpha and Beta Particles by Matter and the Structure of the Atom. Introduction. The cornerstone of our modern understanding of atomic structure. Ernest Rutherford and Hans Geiger's 1910 paper, The Scattering of Alpha and Beta Particles by Matter and the Structure of the Atom, represents a watershed moment in the evolution of physics. This seminal paper, born from the meticulous experimental observations conducted in Rutherford's Manchester laboratory, superseded the prevailing model of the atom, which posited a homogeneous distribution of positive charge punctuated by embedded electrons, often described as the plum pudding model. This examination undertakes a detailed, section-by-section critical evaluation of Rutherford and Geiger's work, focusing intensely on their claims, methodologies, evidence, and the logical coherence of their arguments. The essay will dissect the specific statements made within the paper, analyzing their validity, examining the experimental techniques employed, and exploring the implications of the findings as presented within the work itself. This evaluation will also consider the internal consistency of the presented arguments, the interplay between theoretical propositions and empirical data, and the lasting significance of the conclusions reached. Section 1 Introduction General Statement and the previous framework. The opening section of the paper immediately frames the context for the investigation. Rutherford and Geiger begin by noting the existing understanding, the prevailing views of the atomic structure, highlighting the need for more detailed investigation. They directly state the problem. They are addressing the significant scattering effects observed when alpha and beta particles traverse matter. This initial statement sets the stage by clearly stating the limitations of current understandings. They identify the discrepancy between expectation and observation, laying the groundwork for a new model. The authors establish the rationale for their investigation by focusing on the anomalous behavior of alpha particles, which displayed unexpectedly large deflections when interacting with matter. This observation spurred the need for a new understanding, a new framework for the atom itself. Section 2 Experimental Arrangement and Procedure. This section delves into the careful construction of the experimental apparatus employed by Rutherford and Geiger. Describing their setup, the authors detail the alpha particle source, the collimation system, and the methods used to detect and measure the scattered alpha particles. The experimental chamber's design, filled with a gas, allowed the experimenters to vary the target material and observe the alpha particles' trajectories. The meticulous description emphasizes the precision with which the experiments were conducted. The authors explain the careful process of creating a narrow beam of alpha particles, allowing for a definitive starting point, and the use of a zinc sulfide screen to detect the scintillations produced when alpha particles collided with the screen. The key claim here is the accuracy of the measurement, the care taken, the precision of the angle measurements, and the establishment of a controlled environment all point to the trustworthiness of the observations. The detail provided here allows those repeating the experiment to achieve similar results, a key indicator, a vital aspect of scientific integrity. Section 3 Observation of Scattering. The authors now present their pivotal observations regarding the scattering phenomenon. They describe the detection of alpha particles at angles far exceeding what was previously expected based on prevailing models. These large-angle scattering events, which appeared to defy the predictions of the plum pudding model, provided the first indication of a significantly different atomic structure. Rutherford and Geiger report not only the existence of large-angle scattering but also its frequency and dependence on the atomic properties of the target material. Their crucial observation involves the number of alpha particles scattered at different angles. They find some particles are scattered significantly. The authors meticulously specify that the number of particles scattered at larger angles appeared as the crucial indicator in differentiating between competing models of the atom. Section 4 Development of a Theoretical Framework. This section presents the theoretical framework, that was developed to explain the observed scattering results. Rutherford and Geiger proposed that the atom possessed a small, dense, positively charged nucleus, with a majority of the atom's mass concentrated within this core. This radical proposition stood in stark contrast to the prevailing plum pudding model. They propose that the alpha particles interact with this concentrated positive charge through electrostatic repulsion. The framework presented is the essential formulation of Coulomb's law governing the interaction. The crucial inference made is that the large scattering angles seen could only be explained by the presence of a concentrated positive charge. They state the relationship between scattering angle and impact parameter, the distance of closest approach to the nucleus. This relationship is described mathematically, illustrating how the deflection angle depends on the distance between the alpha particle and the nucleus. The specific equations presented connect the measured angles to the underlying atomic structure. Section 5. Derivation of a scattering formula. The authors then provide a rigorous mathematical derivation of the scattering formula. This formula, based on their model of the atom, predicts the angular distribution of the scattered alpha particles. The derivation meticulously and accurately applies the principles of classical mechanics and electromagnetism to the interaction between the alpha particles and the positively charged nucleus. Each step in the derivation is carefully justified and linked to underlying physical principles. The derivation presented here is the theoretical embodiment of the proposed framework. The formula itself is a direct consequence of the assumptions. They provide the specific prediction for the dependence of the scattering on the energy of the alpha particles, the atomic number of the target material, and the scattering angle itself. This precise mathematical expression is the crucial link between the theoretical model and the experimental observations. The formula's very existence allows for a quantitative comparison between experiment and theory. Section 6. Experimental verification and comparison with theory. This crucial and central section presents the results of the experimental verification process, where the experimental data is directly compared with the predictions made by the theoretical scattering formula. The authors meticulously describe the method for comparing experimental observations with theoretical predictions. This section is critical because it is where the test of the claims is undertaken. The authors specifically investigate the angular distribution of the scattered alpha particles, measuring the number of particles scattered at various angles and comparing these measurements to the predictions of the formula. The agreement between theory and experiment is presented as the evidence for the validity of the scattering model. This comparison is done by examining the rate of scattering at different angles. They note the observed dependence on the angle matches the formula. They note that the observed dependence on the atomic number is verified, as are the dependence on the energy of the alpha particles and the nature of the scattering material. These detailed comparisons provide evidence supporting their model of the atom. Section 7. Discussion of results and deviations. The authors provide a discussion of the results and, importantly, address any observed deviations between the experimental results and the theoretical predictions. They acknowledge that perfect agreement between theory and experiment is never achieved in the real world. They discuss the significance of these deviations with the same level of detail. The authors address potential sources of error in their experiments and explore any discrepancies between the theoretical model and the observed behavior of the alpha particles. The paper clearly details any observed deviations. The authors delve into potential sources of these deviations, such as the finite size of the nucleus, the motion of the nucleus, and the potential for secondary scattering effects. This rigorous assessment of the deviations, the careful analysis of the sources of error, and the cautious interpretation of the results further underscore the scientific integrity of the work. They address possible refinements to the model. Section 8. Conclusion and the new atomic model. In the conclusion of their study, Rutherford and Geiger make a direct statement of their findings and the implications of their work. They state the key conclusion, the scattering of alpha particles, is consistent with the hypothesis of the nuclear atom. They concisely summarize their main findings. and provide a clear and comprehensive description of the new atomic model. This model proposes that the atom consists of a small, dense, positively charged nucleus surrounded by orbiting electrons. The nucleus contains the majority of the atom's mass and charge. The authors present the conceptual shift required to understand the atom. They present the profound implications for the understanding of matter. The authors reiterate the key features of this new model, emphasizing its simplicity and its ability to explain the experimental observations. They mention the limitations of the model and discuss the next steps for future investigation. The authors conclude by underscoring the transformative impact of their findings on the field of physics. Section 9 Examination of the methodological choices. The choices made by Rutherford and Geiger in terms of methodology are essential when critically evaluating the work. They opted for a scattering experiment, the selection of alpha particles as the probe and the choice of target materials were critical decisions. The reasoning behind the selection of alpha particles as probes is rooted in their known charge and relatively large mass, making them suitable projectiles for probing the structure of the atom. The selection of different target materials allows for examination of the scattering effects across various elemental compositions. The selection of a detector is another critical methodological choice, based on the need for a detector capable of distinguishing individual alpha particles. The choice of a scintillation screen is then justified. Careful calibration and the control of experimental variables are also vital. The ability to control and vary the experimental parameters, such as the alpha particle's energy and the target material, contributes to the accuracy of the observations. The meticulous approach to data analysis, including error estimation and addressing potential sources of uncertainty, further underscores scientific rigor. Section 10 Assessing the evidence and its interpretation. The evidence presented in the paper must be critically evaluated, especially how the authors interpret their observations. The evidence is provided by the data measured. The focus lies on the experimental observations and the quantitative analysis of the scattering patterns, the large angle scattering and the dependence of the scattering on the target material's atomic number are core pieces of evidence. The interpretation hinges on the correlation between the observed scattering patterns and the proposed nuclear model. The authors interpret the observed large angle scattering as evidence for a concentrated positive charge within the atom. The dependence of scattering on the atomic number provides information on the charge found within the nucleus. The interpretations of the findings are carefully connected to the theoretical framework. The author's interpretation of the evidence demonstrates the intellectual care exercise. Section 11 Look at the limitations and subsequent development. The original paper, while revolutionary, possessed certain limitations that became apparent in subsequent work. The model proposed, while a significant advance, did not account for the stability. The question of why the electrons did not spiral into the nucleus was a major outstanding issue. The development of quantum mechanics during the following years ultimately addressed these limitations. This new framework explained the stability of atomic structures. The later advancements, building upon the work of Rutherford, ultimately created the quantum mechanical model of the atom. The original work, therefore, should be recognized for its groundbreaking nature, but the inherent limitations should also be noted. The limitations do nothing to detract from the paper's importance. Section 12. The enduring significance of the paper. The enduring influence of Rutherford and Geiger's 1910 paper on our understanding of the atomic structure cannot be overstated. It serves as the foundation for the subsequent development of atomic physics. The paper directly influenced the development of the atomic model, which in turn shaped every subsequent advancement. The work provided the foundation for Niels Bohr's model. The work laid the groundwork for the development of other advancements, from nuclear physics to materials science and beyond. The paper's influence extends beyond the scientific realm. The work serves as a model of scientific rigor and exemplifies the importance of methodical, empirical research. The work has also become a classic example of how experimental observation can overturn long-held assumptions. The paper, therefore, continues to inspire. Conclusion. In conclusion, Rutherford and Geiger's 1910 paper, The Scattering of Alpha and Beta Particles by Matter and the Structure of the Atom, is a landmark in the history of science. The study offered an unprecedented framework for understanding the atom through meticulous experimental design, rigorous data analysis, and careful interpretation. The authors presented compelling evidence to support their revolutionary model of the atom. The profound implications of their work continue to resonate throughout the field of physics. The meticulous approach to the work from experimental design to theoretical framework remains a model for scientific inquiry. While the model presented here contained inherent limitations, the paper's significance to the development of modern physics is undeniable. The work therefore stands as an unwavering testament to the power of observations.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.